Unit 6, Section 1, Reversing Differentiation. In other words, indefinite integral. Section objectives. By the end of this session, the student will be able to 1. Integrate polynomials. 2. Evaluate definite integrals. Indefinite integral. To integrate x power n, we increase the power by 1 and divide by the new exponent. This means that if x is raised to the power n, then we have x to the power n plus 1 divided by n plus 1 plus c as our indefinite integral of x power n. Let's note that when x is raised to the power -1, meaning if n is -1, and we are to integrate that, by increasing the exponent by 1 means we have x raised to the power -1 plus 1, then divided by the new exponent -1 plus 1. Now -1 plus 1 is 0. So if we divide x exponent 0 by 0, it will be undefined. So hence, the n can take all values except -1. Now also, if the first derivative dy over dx is given as kx power n, then to find the indefinite integral, we factor out the constant k, so that we have y equals to k, the integral x power n dx plus c. Now integrating x power n, we have x power n plus 1 divided by n plus 1 plus c. Example, evaluate the following indefinite integrals with respect to x. A, the integral 3x squared dx. B, the integral 3 minus 2x dx. C, the integral x plus x squared dx. Solution. A, given the integral 3x squared dx, we know that 3 is constant, so we factor the 3 out. Then we have 3, the integral x power 2 dx. Now integrating x power 2 dx, then we multiply it by 3, gives 3 over 2 plus 1 x power 2 plus 1. That is, we increase the exponent by 1, divide by the new exponent, then plus c, which is simplified to have x power 3 plus c. The b, if the integral of 3 minus 2x dx is given, then this gives the integral 3 dx minus the integral 2x dx, then plus c. Now the 3 is a constant, so we factor it out so that we have 3, the integral dx. Again, we factor the 2 out, then we have 2, the integral x dx, then plus c. Now, if we integrate dx, then it gives x. If we integrate x, then it gives x squared over 2, multiplying by the coefficient 2, and that gives 3x minus x squared plus c as the answer. C, given the integral x plus x squared dx, to integrate this, we increase the power of x and divide by the new exponent, and that gives x squared over 2 plus we increase the power of x power 2 by 1 dividing by the new exponent. That gives x power 3 over 3, then plus c. And that is why the answer is 1 over 2x squared plus 1 over 3x power 3 plus c. Definite integrals. The process of finding the exact value of an integral within a given specified interval is referred to as definite integrals. For example, if we want to find the integral of a function f of x with respect to x within the interval x is from a to b, then we are finding the definite integral of that. And this is written as the integral, the lower limit a, the upper limit b, then f of x dx. The a and b are the limits. The a is the lower limit, and then the b, the upper limit of the integration. Definite integrals. If you are given the function capital F of x, which equals the integral f of x dx, then the definite integral is evaluated as the lower limit a, upper limit b, f of x dx, which equals to capital F of b minus capital F of a. This means we integrate the given function small f of x, which gives the capital F of x. Then we put in the limits. We put in the upper limit first minus we put in the lower limit. Example, evaluate the following definite integrals. A, the integral, the lower limit 1, upper limit 3, 3x squared dx. B, the integral, the lower limit negative 2, the upper limit 5, x squared plus 2 dx. C, the integral, the lower limit negative 1, upper limit 1, 3x squared minus 4x dx. Now, A, to evaluate this definite integral, the lower limit 1, upper limit 3, then 3x squared dx, we first integrate the function by increasing the exponent by 1 dividing by the new exponent, which gives x to the power 3. Then we now put in the upper limit minus when we put in the lower limit. So this gives 3 to the power 3 minus 1 to the power 3. 3 to the power 3 is 27. 1 to the power 3 is 1. When we take 1 from 27, the answer is 26. B, to evaluate the integral, the lower limit negative 2, upper limit 5, x squared plus 2 dx, we integrate the function first by increasing the exponent and dividing by the new exponent. And the integral of the function gives x to the power 3 divided by 3 plus 2x. Then we now put in the upper limit, which is 5, then minus putting in the lower limit negative 2. So when we put in the upper limit 5, then 5 exponent 3 becomes 125, then divided by 3, plus 2 times 5, which is 10. Then minus negative 2 exponent 3 is negative 8. Then multiplying 1 over 3 gives negative 8 over 3. Then 2 multiplying negative 2 is negative 4. Now this is simplified to give us 175 over 3. C, to evaluate the integral, the lower limit negative 1, upper limit 1, 3x power 3 minus 4x, we first integrate the function. Integrating the function, we have 3x power 4 divided by 4 minus 4x power 2 divided by 2. And this gives 3 over 4x power 4 minus 4 over 2x power 2. Now putting in the limits, then we have 3 over 4 minus 2, then minus 3 over 4 minus 2. And this gives 0.